Yeah, hi. So welcome to our video, and in this we are solving today's lead code problem, and it was the fourth problem. And yeah, it is a simple problem if you are able to get it, but if not, then it can be tricky as well. Okay, so let's see what's the problem statement here. So we have an integer n representing the number of nodes in a perfect binary tree consisting of nodes numbered from 1 to n. The root of tree is 1 and each node I in the tree has two children, where the left child is 2 into I and the right child is 2 into I plus 1. Each node in the tree also has the cost represented by zero indexed integer array cost of size n, where cost I is the cost of node I plus 1. You also increment the cost of any node by 1 any number of times. Return the minimum number of increments you need to make the cost of paths from the root to each leaf node equal. Okay, so basically we have the value n and cost. Okay, so one thing is here that we don't have the entire tree structure with the help of nodes and everything. We simply have this n is equal to 7. That means we have 7 nodes in our tree. Okay, and this is a perfect binary tree, so that means 7 plus 1 will be a power of 2, because we know that number of nodes in a perfect binary tree are given by that formula only. Okay, so our task is that we want to go from root to the leaf. Okay, so सबसे पहले अपने लोग 1 पे हैं, then we go to 2 and then we go to 5. So the cost here is 1 plus 5 plus 3, that is 9. And when we go from 1 to 4, then our cost will be 1 plus 5 6 plus 2 8. And similarly here from 1 to 7 via 3 will be 4, 1 plus 2 plus 1. Okay, so now our task is to increment the cost value by 1, and then we have to make the cost for each path equal. Okay, so I hope the problem statement is quite clear to you. So let's see how this problem will be solved with the help of this Jamboard. Okay, so see, first of all, let's say we come from this 1 to this 2. Okay, now we are at this 2. Now we want to go from this 2 to all the possible leaf nodes possible. So one of the possibility is 4 and other possibility is 3. Okay, so 4 is a leaf node and 5 is a leaf node. And then we can say if we go from, see, cost 1 plus 5 is common for both the paths, right? The difference is these costs, which is 2 and 3. So when we are at this 5 cost value, then we can see that we have to add 1 in the left subtree. Then only the path will be equal, right? So it is obvious that we have to add plus 1 here. Okay. Similarly, when we are at similarly when we go from this 1 to this 3, now we have now this 1 plus 2, they two are common in both the paths. So that means now the path from 3 to 6 and path from 3 to 7 should be equal, but they're not equal. So what we can do is we can see that we have to add the extra 2 here, right? So that means what we can do is we can write a simple recursive solution in which we will find out the left cost and the right cost, and we will add the extra path, basically the absolute of left minus right, into our answer. Okay, so this is the logic. Let's code it out. So here it will be return fun. Initially we are on 1, and in this we don't need to build the entire tree. We can simply use 2 into I and 2 into I plus 1 for the childs, and we can simply write the solution. We will see how we will be writing the solution. Yeah, so one more thing, because when we will be returning the cost, and we don't have to return the cost, we have to return the increments that we made. So we have to use a variable to store the answers. So that means we'll not be returning this, and here will be answer. here will be cost, and finally we will be returning this answer. Now we have to write this int fun, int I, int, and we will be passing the reference to this answer, and then this vector int cost. Okay, so let's write the recursive solution. What will be the lift cost? The lift cost will be fun. So the lift child will be 2 into I answer comma cost. And similarly, we can write the cost for the right value as well. 2 into I plus 1 and this. Now answer, for answer what we will do is we will simply write answer is equal to answer plus absolute of left minus right. And here what we will do is we will simply return. So see, now we have to analyze that what we have to return here. So see, because we are returning the cost, right? So let's say we are at this 2 and we want to return the cost. So what we will be returning? We will be returning the maximum of 2, that will be 3 plus 5. So here we will be writing return cost, and because this I is one indexed based, so we have to convert it into 0 based indexing. So that's why we will be writing cost I minus 1 plus max of left comma right. So yeah, now we will also have to write the base case. So the base case will be if I will be greater than n, then we have to return 0. Okay. Now we don't have n here, so what we can do is we can write a private variable here, int n, and let's say this is capital N, and int n, n is equal to capital N. Okay. So yeah, let's check it out whether it is working or not. Yeah, so it is working for the sample cases. Let's run it. And yeah, it is accepted. So see, it was a pretty simple solution, and by seeing the standard of the fourth question, it was quite easy to solve. Okay, so I hope you got this point, that why we are simply adding the absolute of left minus right cost, because let's say we are at this 2 and we want to go to all the possible leaves, so the left as well as the right cost should be equal, because the upper part are same in both the paths. The only difference will be for the bottom parts, and that's why we will have to add the extra value in one of the two trees, subtrees basically. Okay, so yeah, that's it from my end for this video. I'll be making more videos for the problems, and if you like my video, then do subscribe to the channel and do give the comments and like the video as well. Okay, so yeah, bye then.